Hey everyone, welcome to the 3.1 Factors Notes. Today we're going to be talking about prime numbers, composite numbers, and factors. So if you'll do me a favor and make sure you have a highlighter. They are in my room on the top shelf of the bookcase underneath the TV on the right side. Make sure everybody has one. While you guys are getting that, I'm going to explain prime and composite numbers, and I'm just going to highlight these two main words. So once you get your highlighter, go ahead and highlight prime and composite. A prime number is a number that is only divisible by 1 in itself. It's the type of number that you would mainly say nothing goes into. For example, the number 7. Nothing goes into 7 except for 1 in itself. So there does not exist a number that nothing goes into, because a number can always be divided by itself. And when we say divisible by or goes into, we mean evenly without a decimal. A composite number is the opposite of a prime. So, for example, I'm going to take my pencil and I'm going to cross out the number 14 because I know that 7 goes into 14. So that's another number besides itself, so 14 isn't prime. And we're going to try and find all the prime numbers between 1 and 60. And I'm going to circle the 7 now. I highlighted it, but I'm also going to circle it afterwards because 7 is prime. You can cross out the multiples of any number because that number goes into them. So I'm going to cross out 14, 21, 28, 35, 42, 49, and 56. Now that I have those all crossed out, take a look at mine, take a look at yours, make sure you have them crossed out as well. And then I'm going to circle another prime number that I know of. Well, I know that nothing goes into 5. So I'm going to cross out 10, 15, 20, 25, 30. Any pattern you notice here? Hopefully you know 5 goes into numbers that end in 5 or 0. So I'm going to cross out all of these numbers that end in 5 and all of the numbers on the right side that end in 0. So those two columns, the 5s and the 10s, should be completely crossed out. And then I'm going to do the same thing for 3s. Circle 3, but then cross out any multiple of 3, like 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60. Now, if that's too much for you, go ahead and just watch and circle the numbers afterwards so you just have your prime numbers circled. That's one way of doing it. And I'll go ahead and highlight them so they're a little easier to see. And then the last but not least, I'm going to do 2s. So 2 is a prime number because it can only be divided by 2. But now I can cross out anything left that's even. Like 4 can be divided by 2. 8 can be divided by 2. 16 can be divided by 2. So look for any numbers that end in a 2, 4, 6, 8, or 0. Okay, if I do that on the third row, 22, 26 get crossed out. On the fourth row, 32, 34, and 38 get crossed out. In the 40s, 44, 46, and in the 50s, 52, 58. So you should notice that the columns that don't have any prime numbers left, that we ended up crossing out the whole column, are here, 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 because those are all even numbers. So every other column is even, so it can be divided by 2. And if it can be divided by 2, it's not prime, unless the number is 2 itself. So the prime numbers are 2, 3, 5, and 7 in the top row, and then 11, 13, 17, 19, 23, 29, 31 and 41, 43 and 53, 37 and 47, and 59. Notice how pretty much all of those prime numbers, except for 2, 3, 5, and 7, all of the others end in a 1, a 3, a 7, or a 9. So no prime numbers will end in an even number or a 5. It has to end in a 1, 3, 7, 9. That's pretty much it. Those are prime numbers, friends. Now let's talk about factors for a minute. Part of the reason why those numbers are called prime is because they don't have factors. A factor is a number that the number you're given can be divided by evenly. So, for example, if I want to list all the factors of each number listed in this example down below, what I can do is try to take that number, like 30, divided by 1 in my calculator. And now I'm going to use the calculator that's over on the right side, so you pay attention to both. So that gives me 1 and 30. 1 times 30 is 30. Okay? And actually, before I get going too far, let me go ahead and pause. If you haven't highlighted or circled all of your prime numbers, go ahead and do that. And then we'll move on to the factors. There, that might make it a little easier to see, a little less messy. Okay, so 30, what you're going to do is try dividing by 1, then 2, then 3, then 4, then 5, and you're just going to use your calculator to then do 30 divided by 2. Oops. 30 divided by 2 is 15. So 2 and 15 is a factor pair of the number 30 because they multiply to 30. 30 divided by 3 is 10, so 3 and 10. 30 divided by 4 is a decimal, so I'm not going to include that. And I'm going to move on to 30 divided by 5. Don't just stop because you got one decimal. The next number might still work. Now, I got 5 and 6, which is where I stop, because the next number I would try would be 6, and it's already on my list. Those are all the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. 30 can be divided by any of those numbers, but nothing else. And if you go in order like I just did, you'll get every number every time. Now let's try 31. 31 divided by 1 is 31. But then 31 divided by 2, and 31 divided by 3, and 31 divided by 4, like none of these are working. I usually give it until I get to the number 5, 6, 7. If 7 still doesn't work, then it's probably that nothing works. There are prime numbers bigger than this, but if we do something, let's go take a look. Look, 31 was on our prime list. That's why those are the only factors of 31. So I'm going to write the word prime underneath so that you remember. That's why the list is so short. And then I'm going to do this exact same thing with 45 and 87. 45 divided by 1. 45 divided by 2. Decimal. 45 divided by 3. 3 and 15. Notice how I'm writing down the number I divided by and the answer, because they're both factors. And then 45 divided by 4. Nope. 45 divided by 5. Yep. 5 times 9. 45 divided by 6. Nope. 45 divided by 7. Nope. 45 divided by 8. Nope. And I'm not even going to do 45 divided by 9 because 9's already on my list. Okay, I'm going to give you a hint for 87. There's going to be 2 different rows of answers. I want you to see if you can find both of them. All right, 87 divided by 1 is 87. 87 divided by 2 shouldn't have worked, but 87 divided by 3 is 29. Now, there's still a lot of numbers between 3 and 29 to check. I will give you a hint that one reason why you can tell that this won't go any further is that 29 is a prime number. Nothing goes into 29, so there's no smaller number that will be on that side of the column. For example, if I look back at the 15, 5 and 3 both go into 15 again. That's why there were more numbers left to check. And those are the factors of 87. 1 and 3, 87 and 29. And we call these factor pairs because there's 2 of them put together. Okay, now let's talk about the yearbook committee. The yearbook committee is planning out how 24 photos will fit on a page, but we can't put more than 10 photos in a row. Okay, so think about there's only so much space. So this involves factors because when you line out photos, when you line out photos on a page, you're basically doing rows and columns. Like this would be 3 rows of 4 or 12 because 12 photos because 3 times 4 is 12. So I need to find 2 numbers that multiply to 24, like 3 times 8. So I could do 3 rows of 8 or 8 rows of 3. It is not the same thing. 3 rows of 8 would be 1, 2, 3, and then going 8 across. And 8 rows of 3 would be 3 going across and 8 going up and down. So either of those would work. What else multiplies to 24? 4 times 6, so 4 rows of 6, or 6 rows of 4. What else multiplies to 24? We've used 3 and 4. What about 2? You could do 12 rows of 2. Could we do 2 rows of 12? No, because we can't put more than 10 photos in each row. So because of that 12, we can't do that one. So there's 1, 2, 3, 4, 5 different ways to lay out these photos. So yearbook committee has 5 different choices to pick from if they know they have 24 photos. Okay, there might be one question on your assignment too that asks you how many different ways something can be arranged. If you're talking about rows and columns, you just need numbers that multiply to how many you have. The only difference about the no more than 10 in a row, that's why we had to cross out this last one. That's why there's only 5 ways instead of 6. Okay, now the last topic for today is called prime factorization. Prime factorization is where you write a number as a product or a multiplication of prime numbers only. So we're going to break these numbers down as far as they can go. Let's take a look. The first number is 630. To start with, you just need to find 2 numbers that multiply to 630. Now, I'm not going to use my calculator for this one because I noticed that 630 ends in a 0, which means that something times 10 equals 630. And that number is, if you imagine the 0 going away for a second, 63. So anytime a number has a 0 at the end, if you divide it by 10, you're just taking away the 0. Then what we're going to do is branch off until there's no more left. So 63. I don't know what goes into 63 as easily, so I'm going to try 2. Didn't work. Try 3. 3 times 21. And I'm going to keep going with these numbers. 3 is done. Nothing else goes into 3, so I want you to circle it so that you know that one's done. Then 21, 2 didn't work, but 21 is 3 times 7. And notice how I'm using division in my calculator to figure out my multiplication facts. You can use your calculator in this way. You don't have to have like a multiplication table. And 3 and 7 are both prime, so we're going to circle those. Notice how I didn't circle 21 or 63 because they kept breaking down. They had factors. Then I'm going to do the same thing with 10. I'm really hoping that we know 10 is 2 times 5. And nothing goes into 2 or 5, so I'm going to circle 2 and 5. And that's it. Every number that could break down has been broken down as far as it can go. So now what we do is we write the product. We say that 630 is the same thing as 3 times 3 times 7 times 2 times 5. All of the numbers that I circled. Sometimes there's only going to be 2 numbers. This time there was 5. Then what I want you to do underneath, we don't want to list the 3 twice. 3 times 3 is the same thing as 3 squared. That's going to be our final answer. So instead of writing 3 times 3, we're going to write 3 squared. I don't care what order you write the answers in. There are some textbooks that have you write it like this, where you're going from least to greatest. But I don't care what order you write them in. What I do care about is that you realize that instead of writing 2 3s, you could just write 3 squared. So now 630 is being written as a product or multiplication of only primes. And if you want me to prove it, 3 to the power of 2 times 7 times 2 times 5 is 630. So you can easily check your answer if you need to. Let's try 32. 32 divided by 2 is 16. So 16 times 2. 16, I know that 16 is 4 times 4. If you thought 16 was also 2 times 8, you could have done that as well. As long as it's something that multiplies to 16, you'll get it correct in the end. And then 4 is 2 times 2. And the other 4 is also 2 times 2. So you're doing a little v off of any number that has more things that go into it. And then the 2 at the top doesn't go any further, so I'm actually done with this problem. You're just trying to break the numbers down as far as they can go. Now, I only have 2's circled, and there is 1, 2, 3, 4, 5 of them. So 32 is the same thing as 2 to the power of 5, because there's 5 2's. Let's try 56. So 56 divided by 2 is 28. So I get 2 and 28. It doesn't matter what numbers you start with as long as they multiply to the top number. Then 28 is 4 times 7. And nothing else goes into 7, so I'm going to circle it. And just like on the last one, I know that 4 is 2 times 2. And then that 2 at the very top, nothing branches off from 2, so you just circle it. Now this time I have 1, 2, 3 2's, and a 7. So 2 cubed times 7. All right, let's try a few more. It just takes a minute to get the hang of it. I'm going to do 59, and then I want you guys to try 180 and 83 on your own. All right, 59. 59 divided by 2, or 3. Man, guys, nothing goes into it. They all gave me decimals. When that happens, what I want you to do is look at the top. There's a reason we listed every number between 1 and 60 that's prime. And 59, look at that. It is prime. So what that means is it doesn't have a prime factorization. What we do is we say prime. Never should the number 1 show up in a prime factorization tree. Okay, you might have called these factor trees, but it's called prime factorizing because you're factoring it all the way down until you get only prime numbers. Okay, I want you guys to try 180 and 83 on your own. We'll go over the answer, and then you guys will have the rest of class for homework time. All right, here we go. So I'm going to pick a bigger number. And you didn't have to. Actually, you know what? I'll do 2 because I have a feeling a lot of you maybe tried the number 2. And if you did something different, please don't erase yours yet. If you're still working on it, go ahead and finish, and then then check your work with mine at the end. But our answers or work might look a little different in the meantime. So here we go. 2 times 90 is 180. Nothing else goes into 2, so I circle it. 90 ends in a 0, so I know that that's 9 times 10. And 9 is 3 times 3. 10 is 2 times 5. And that's it. No other numbers go into 3, 2, or 5. So then you just have to sort of count up what you've got. I see 2 2's, So I'll call that 2 squared. And I see 2 3s. So that'll be 3 squared. And then I see a 5. Okay. One quick thing about notation, you are multiplying all of these together because prime factorization is the product, and product means times. Okay, what about 83? Did anybody find anything that goes into 83? Probably not, because guess what? 83 is prime. If you're not sure, try 83 divided by 2, 83 divided by 3, 83 divided by 5. Oops, I skipped 83 divided by 4. 83 divided by 4. 83 divided by 6. 83 divided by 7. 83 divided by 8. 83 divided by 9. None of those worked.